Hello everyone. This question has been taken from Irodov, Fundamental Equation of Dynamics, question number 70. A horizontal plane with the coefficient of friction K supports two bodies, a bar and an electric motor with a battery on a block. A thread attached to the bar is wound on the shaft of the electric motor. The distance between the bar and the electric motor is equal to L. So when the motor is switched on, the bar, whose mass is twice as great as that of the other body, starts moving with a constant acceleration W. How soon the bodies collide? So let us solve this question. This is your bar and this is your motor battery kept on a block, whole thing together. The mass of this entire thing is m, and the mass of the bar is twice of this entire thing, that is 2m. Both the bar and the motor shaft is connected with the thread. So when the motor switched on, the shaft start turning. So the threads start wrapping on this shaft. And at that moment, at that time, when the motor is switched on, the bar starts traveling with a constant acceleration W towards the motor and its mounting, right? Okay, and now this motor and the mounting also is not fixed. So this also start traveling towards the bar with an acceleration W1. So we have assumed that this started traveling with an acceleration W1 towards the bar. Okay. There is nothing mentioned about this thread. So we should assume that this thread is massless. And also nothing mentioned about the shaft frictions. So we should assume that shaft is also frictionless. So because the thread is massless, the tension at each and every point of the thread will be equal, and that we have notated with T. Since this bar is moving in this direction with W acceleration, so it will experience a friction force from the ground, and that we have notated by small f. And this entire assembly, motor plus battery plus block, is moving in this direction with W1. So this is experiencing an friction force from the ground that we have notated with F1. Okay. Vertical we have taken as y-axis, horizontal we have taken as x-axis. The weight of the bar is acting downward, that is equal to 2 mg, and the normal reaction of the ground we have notated as n, which is acting on the bar. The same way, weight of the motor plus battery plus block mg is acting downward, and normal reaction force from the ground to this assembly is n1. Initial gap between the bar and the motor assembly is L, which we have shown here. So we have to find the time, at what time both bar and motor will collide with each other. Both the bodies will collide with each other. So that we are saying that at t time it is colliding, and t we have to find. So this is the write-up. You can go through what I have written for your convenience. Okay. So let us write Newton's law of motion on bar in the y direction. In the y direction, only two forces are acting. One is the normal reaction and one is its weight. So N is acting upwards, so N positive. Weight is acting downwards, so weight is written negative. And there is no acceleration in the y direction. So therefore, N minus 2 mg will be 0 and N will be equal to 2 mg. Now we will apply the Newton's law of motion for motor, battery and block together in the y direction. Two forces are acting in the y direction. One is N1, the normal reaction force, by the ground to this entire assembly, and one is its weight, which is acting downwards. So N1 is acting upwards, so we have taken it positive, and weight is acting downwards, so it is coming with negative sign. There is no acceleration in this direction, so this will be equal to 0. So N1 is equal to mg. Now by the friction force formula, we know that F will be K into normal reaction force, means coefficient of friction into the normal reaction force. So K into N. So we put this N value of N from here. So this is 2K mg. Similarly for F1, it is K into mg. If we take the NLM on bar in the x direction, we can write summation of force in the x direction will be equal to the mass of the bar into acceleration. So summation of force in the x direction is, one is the T, right? And so T is in the positive direction of x-axis. T is positive, minus F, because it is acting in the opposite direction of T. So we have taken it as minus F, mass into acceleration to 2m into W. So this we got number 3 equation. Similarly for motor, battery and block, if we are taking T in this direction as positive, so F1 will be coming as negative because these two forces are in the opposite direction. So T minus F1, and your motor is moving in this direction towards in the direction of T. So T we have taken positive, so W1 we will also take positive, so M into W1. Now if we deduct equation 4 from 3 and equate, we will get W1 is equal to 2W plus K into G. So this is equation number 5. Bar is moving in this direction, in the positive x direction with W, and motor is moving in this direction, that is in the negative x direction with W1. So acceleration of approach between the bar and the motor plus mounting is W minus W1, because motor is traversing in the negative x direction. So then this acceleration of approach will be W plus W1. We will put the value of W1 from equation 5. So W plus 2W plus kg. So 3W plus kg. Now we will write the equation of motion. half into WA, acceleration of approach between the bodies, into t squared. T time we are taking that at which time both the bodies are colliding with each other. So this will be equal to the total distance or total gap between the bar and the motor. So that is equal to L. So from here we will calculate T is equal to square root of 2L by 3W plus kg. So this is your answer. So this you should understand why we have taken velocity of approach. You could have written other way also, like, okay, you could have written that, okay, this bar has moved L1 distance towards the x direction and motor has traveled an L2 distance in the negative x direction, and L1 plus L2 is the L, because after covering this distance they are colliding with each other. The same thing, in fact, it is the shorter version of writing this way, that we will take the acceleration of approach. So acceleration of approach means total acceleration towards each other is this. Okay, so in t time, so what distance it will travel? The total distance it will travel, L. So half WAT square will be L, and then T will be this much. So this is your answer. So hopefully the answer is clear to you. In case any doubt, please do let me know. Thank you.